Buenos dias. Good morning, everybody. Welcome to day 3 on week 1 of the summer semester for Chemistry 104. I hope everybody's having a great day. Good morning to the students in the chat. Buenos dias, everybody. I hope everybody is ready to go over some material. Today, we will be finishing chapter 3, and then we're going to move on to chapter 4. Now, when it comes to attendance, you guys, as you were coming in and populating the participants list, that's where I took attendance. So I'm not going to verbally take attendance. I already annotated all of you guys that are here. And for the students that are coming in, similarly, as you guys are coming in, then I already annotated that you are here. So a few things before we continue. Remember that when it comes to this week, tomorrow is the last day that you can submit the extra credit quiz for the class content and syllabus. By Saturday, you need to complete your exam number 1. By Sunday, you need to complete chapter 2, chapter 3, chapter 4. And you guys also have an extra credit quiz for exam 1. Remember that the syllabus extra credit and the exam 1 extra credit are optional. Those are if you guys want to get some points. Now, in addition to that, there's only one more thing. Give me a moment. No, I think that's pretty much it for this week. Remember that lab 1 and lab 2, that's due next week. So that's going to show up in the Outlook for week 2. And the OLAB's website is working. So remember that the reason why I suggested that you guys register is just because I think lab 3 is the only one that if you don't have a registration, it doesn't show up. But understand that if you click on it and it opens, then the registration is honestly optional. Gia, what's your question about labs? Oh, yes. So the labs is next week. And remember, next week on Monday, we do not have class because Palmer College is observing Juneteenth, which is actually celebrated on Sunday. So understand that next week on Monday, we do not have class. We only see each other from Tuesday through Thursday. Excellent. So before we get started, are there any general questions before we continue? Correct. 6:20 next week on Monday, there's no class. Excellent. Since there are no more questions, let's continue talking about the last topic that we mentioned in class. There's a question in the chat. Yes, the chapter quizzes you need to complete on your own. And you must submit it by Sunday, which is June 19th by 11:59. Remember that in this course, the only assignments that are timed are going to be your midterms and the final exam. So any examination is going to be timed. The chapter quizzes, the lab quizzes, the extra credit quizzes, they are not timed. So those you can go in and out. So please be mindful to not press the submit button, because once you press submit, the only one in which you have multiple attempts is the lab quizzes. So if you mistakenly click submit, I cannot start the quiz, because in the chapter quizzes, in the extra credit quiz, at least for those which you only have one attempt, you will be seeing the answer, so I cannot open it for you again. And then remember, tomorrow we're playing Kahoot to review for the exam. And that's about it in terms of announcements. So for those of you that are wondering what's actually on the exam, since I opened Canvas last week, I already posted to you guys exam 1 study guide. So in the study guide, you can see the majority of the items that I talked about in class. As I suggest in every study guide, if there's any topic that was not included in the outline that I gave you, please make sure that you write it in. So if you want to know what you need to study for the exam, please go and revise the study guide that is already available to you in Canvas. So the cutoff for the exam is chapter 4, which is what we are going to end up tomorrow. Understand that in the summer courses, because we only have 6 weeks, and in 6 weeks we have to cover so much material, as you guys are learning along, you need to keep up with the material, because you may be learning something on Thursday and then you're going to have an examination Thursday or Friday, whenever you choose to take your exam. So it's very important that when it comes to this, you guys keep up with the work. So for this exam, the cutoff is specifically chapter 2, 3, and 4. Yes, that's correct. The chapter quizzes are not timed. The exams are timed. Give me one moment to make sure that my computer is able to connect to Zoom. Any other questions while I connect my iPad back to Zoom?
Professor, I have a question.
Yes, go ahead there.
So, okay, if we decided that we wanted to take it as like the exam as soon as it opens, when does it open? Like Friday midnight or?
Yes, Friday midnight.
Okay, thank you.
Let me stop sharing. Let me reshare.
I have one more question.
Give me one moment. Let me just make sure that this is connecting.
Okay. No, I'm just here.
Go ahead.
Oh, question regarding the labs.
Yes.
So for lab 1 and 2, basically I printed everything out and viewing the videos. So then I just keep my data on the sheets that are attached to each of the handouts and then do the quiz. Is that it?
That's it. When it comes to the quizzes, you don't need to print the lab sheets. They are good. They are good for answering the lab quizzes. So for those students that may not have printing services at home, and you know, you don't have the facilities to print, do not worry. You just need to take annotations on the parts of the lab sheet that you have. So there's going to be some lab sheets that are questions based on what you do. So again, if you're able to print, go ahead and print it. If you're not able to print, that is okay. Just make sure that you write down the observations from the questions or the tables that are given to you in the data and observation section in the lab sheets, and understand that the information that you gather in the lab and the background of each lab is what is incorporated in the majority of the questions for the lab quiz.
Okay, thank you. So basically the lab quizzes are what's satisfying our lab requirement as far as assignments. All right, okay, so lab 1 is just basically doing types of separation. Is that correct? And then lab 2 goes into more detail, but as long as I go through, record my data, then I can do the quiz, and that's it. Thank you so much. Sorry for interrupting.
No problem. The thing is that sometimes students confuse the whole idea of OLabs. I understand that if you have taken other courses, including Chemistry 100, you maybe used other platforms for virtual labs. The difference between OLabs and other platforms is that OLabs have no recording of what you did. They do not collect your data. Your data is not saved. I am using OLabs as a free resource for you guys to perform and observe how certain experiments are done. So understand that in this class, how you obtain points for lab, it is by answering the lab quizzes. And remember that for lab quizzes, you guys have 2 attempts in order to complete the points. So if you are satisfied with the points that you get on your first attempt, you don't have to redo your quiz. But again, if you're a student that maybe in the first attempt, you didn't gather the points that you wanted, remember that you have a second attempt for your lab quiz.
Correct?
I didn't hear your question, Victoria.
For lab 1 and 2, is that correct?
Wait, say that again.
The OLab, is it going to be used for lab 1 and 2?
OLabs is utilized for lab 1. Lab 2 is based on YouTube videos. And then you see that sometimes we use OLabs as our resource. Other times the assignment is viewing YouTube videos and answering questions. That's pretty much how the virtual lab works. Every single lab is not an OLab.
Okay, because I'm looking here at, you know, why don't I just deal with this in your office hour? I don't want to waste your lecture time. Because I'm looking at my handout for lab 1, and under the experimental procedure, it does refer me to YouTube, but I don't see anything that's referring me to OLab.
There is an OLabs portion, but I'll be more than happy to answer your questions in office hours.
Great, thank you very much.
No problem. So let's get started reviewing the last thing that we mentioned in class yesterday. So we learned in class that there is substances around us that we can call matter. And matter is going to have 2 parameters. It must have mass and it must occupy space. We learned that when it comes to matter, we can actually separate them into 2 major classes, which are pure substances, and under that pure substance family, we can have elements, which they are contained in the periodic table, and we can have compounds, which is when we have those elements chemically bond to one another. On the other hand, we can have other types of matter that is called a mixture. And when we have a mixture, remember that this is when we are combining 2 or more substances that are physically mixed, but they are not chemically bound to one another. When it comes to the mixture family, remember that we can have two types of mixtures. We can have homogeneous mixtures, which those are going to be substances that are uniform throughout, and we can have heterogeneous mixtures, which in those we may encounter one component versus the other, but in heterogeneous mixtures, we can tell each of the components because they're visible to the eye. Now, another thing about matter is that we can find it in different states. And give it a moment. There is a delay. I apologize, you guys. Today is one of those days in which technology is just not working properly, but we will do the best we can. So as I was mentioning, matter also has different states, and these physical states are classified as solid, liquid, or gases. There is a fourth state, which is called plasma, but typically because we don't have a lot of examples of plasma, that's why we don't talk about it often. Now, when it comes to the different physical states of matter, as you can see, they can be categorized in terms of shape, volume, the arrangement of the particles, the interactions between the particles, and the movement of those particles. So as I've been doing in all of the lectures, understand that this table you're going to use in exam 1, in which if you're given descriptions of each of the states of matter, you need to be able to categorize if it refers to a solid, a liquid, or a gas. As you can see in table 3.1, solids have a definite shape and a definite volume. Their particles are fixed and they're very close to one another because they have a strong interaction. Those particles tend to move very slowly. And you can see that some examples of materials of matter that are solids include ice, salt, and iron. On the other hand, when it comes to liquids, understand that matter that is found in liquid form, they take the shape of the container, but they have a definite volume. Now, the particles move randomly and they're close to one another. They have strong interactions and the movement tends to be moderate. Lastly, when we have matter that is in gas form, understand that it takes the shape of the container, it fills the volume of the container, the arrangement of those particles is actually random, and those gas particles are going to be far apart. Now, the interaction between those particles is essentially none. That's why we are able to compress gases. Now, the movement of those particles is very fast, and you can see that we also have examples of matter that is found in gas form. Let me try to reshare because I don't see my markings on the slide. I'm trying to connect my iPad to Zoom. Today, technology is just not cooperating. Let me see. Let me try something else. I'm not speaking at this moment. I'm just trying to connect my iPad to Zoom. Excellent. So as you can see, it is important that for exam 1, you are able to have table 3.1. Now, whenever we talk about matter, we also need to talk about the properties that matter has. And a property in chemistry is defined as a characteristic of a substance that can be observed. So when it comes to chemistry, we can have physical properties or we can have chemical properties. And the difference between a physical property and a chemical property is that physical properties can be observed, but you're not going to be changing the identity of the substance. So for example, physical properties include luster, which means how shiny something is, the melting point, the boiling point, which these are going to be temperature related, that allows transitions going from solid to liquid or from liquid to gas, malleability, which means how you can mold it, ductility, which means how you can draw it into wires, the physical state, if it's a solid, a liquid, or a gas, the density, the solubility of something, the odor, all of those are physical properties. On the other hand, a chemical property can only be observed by changing the identity of the substance, meaning that there's going to be a change in the substance that you started with. And as we're going to observe in a moment, the changes that matter undergoes, then we are going to be producing new substances when some of these chemical properties are observed. But when it comes to chemical properties, you can see that some examples include flammability, which means is the ability for this substance to catch on fire, combustibility, if it undergoes the combustion reaction, if it's toxic, the pH of a substance, if it reacts with water, with acid, with air, the ability to create rust, all of those include the chemical property. So now let's actually go over one of the problems in the textbook. You can see that in problem 3.10, that is on page 64 in the textbook, we are going to have a series of descriptions, and you need to determine if they are physical properties or chemical properties. So I'm going to give you guys a minute to read through each of these statements and determine if it's a physical property or a chemical property. So whenever I prompt you to describe for a physical property, we're going to put the letter P. For a chemical property, we're going to put the letter C. So at this time, take a moment, read through each of them and determine if they described a physical property or a chemical property. Excellent. Let's go through each of them. Number one, neon is a colorless gas at room temperature. Is that a physical property or a chemical property? Excellent. That is a physical property. Apple slices turn brown when they are exposed to air. Excellent job. That is a chemical property because they are undergoing oxidation. Phosphorus will ignite, catch on fire when exposed to air. Excellent job. That is a chemical property. At room temperature, mercury is liquid. Great job. That is a physical property. And lastly, propane gas is compressed to a liquid for placement in a small cylinder. Excellent job. Any questions about the difference between physical properties and chemical properties? Now, understand that other than having physical properties and chemical properties, matter can also undergo physical changes, okay? And a physical change is defined as a change in state, meaning that we can change from solid to liquid to gas, okay? And also, if your substance has changed in terms of its physical shape, then that is considered a physical change. The main thing about changes that matter can undergo, they are going to be considered physical as long as there is no change in the identity or the composition of the substance. So if you have the same substance in the beginning, in the end, after the change, then that is considered a physical change. Now understand that phase changes are always physical changes. What are phase changes? It's going to be those transitions from solid to liquid to gas. So now we are actually going to find and define terms that describe the different transitions between the different physical states that matter can have. So when it comes to this, let's first describe, if I have a solid and it goes to liquid, what is that process called? Let's put it in the chat. When I start with a solid and I change to liquid. Excellent job, that's melting. What if I have a liquid and it goes to a gas? What is that process called? Great job, that's evaporation. Now, solids can go all the way to making a gas. And what is that called? That is sublimation. There was a question in the chat. let me just go back to it. The question in the chat is, what is the difference between boiling and evaporation? So understand that the process of boiling is when you have a substance and it starts transitioning from being a liquid to being a gas, okay? So when we are treating that in terms of chemistry, then we have a set temperature when we see that transition from liquid to gas. Evaporation is going to be the whole process in which you started with a substance that is completely liquid and now is completely in gas form. So they are related to each other just because the matter is undergoing the same change, but understand that in general terms, when you say that, for example, something is boiling, for example, if you have water, as water, you see the bubbles forming because there are changes in the surfaces of that liquid, then you say, oh, that is boiling. But then in the process, you say, oh, because of the boiling, my water is evaporating and going into gas form. I hope that that answers your question. Now, understand that these transitions do not only go forward from solid to liquid, liquid to gas, solid to gas. We can also have these transformations happening in a different direction. So there is a term for when gases turn into solid. What is that called? Great job, that's deposition. When a gas turns to a liquid, what is that called? Excellent, that is condensation. And when a liquid turns into solid, what is that called? Great, that is freezing. So understand that when it comes to these physical changes, it is important that for the exam, you understand what are the transitions between the state of matters and what are the terms that we utilize to define them. So when it comes to matter, matter not only undergoes physical changes, but it can also undergo chemical changes. And understand that when it comes to chemical changes, here we are going to have that matter result in the formation of a new substance. And that new substance is going to have a new composition. And because it is a brand new substance, it's going to have new chemical properties, new physical properties. So understand that chemical changes are going to occur in the substance that I started with. We are going to keep the atoms, but the atoms are going to be in a new form because we made a brand new substance. Some examples of chemical changes are represented here in the bottom image of the slide, and you can see that they include iron rusting, because iron is undergoing an oxidation reduction reaction and making iron 3 oxide. When you're burning wood, that wood is turning into CO2, water, and also energy. That's why we see the fire. Whenever we're metabolizing food, understand that when we are ingesting that food, similar to what we're going to learn today when it comes to energy, those biomolecules are going to turn into chemical energy in our bodies. Cooking an egg, baking a cake, electroplating, rotting banana just because it's undergoing oxidation reactions. These are some examples of chemical changes. Now, when we're learning about chemical changes, which we are going to spend some time learning about them in chapter 7, we can see that there are certain hints that can tell us if a chemical change has occurred. So here I have 6 examples of these are hints that are going to tell us if a chemical change has happened to our substance. The first one is the change in color. So a change in color because the substance that is being created has a different color from the starting can give us a hint that a chemical change has happened. Formation of bubbles. When it comes to the formation of bubbles, remember that that brand new substance that is being created in our chemical change may be in gas form. So the bubbling comes from the gas trying to separate itself from that liquid. Not all bubbles represent chemical change because, for example, if water is undergoing the process of evaporation, that bubbling is not a chemical change because you're just transitioning liquid water to steam, which is water in gas form. So this formation of bubbles refers specifically to the creation of a brand new substance that is found in gas form. A change in odor can also represent that a chemical change has happened. So for example, if you have food that is rotten, understand that that odor that comes from spoilage is also representing a chemical change. The formation of a precipitate. And in chemistry, a precipitate is basically a compound that is found in solid form. So whenever we are doing a reaction and then one of the new substances that is created is in solid form, then that's what a precipitate is. And you can see here in the beaker that when a clear liquid is added, you can see that yellow content, that is the precipitate forming. The last two hints, first we have warming or cooling. Understand that thermal energy, which is another word for heat, when is being absorbed or is being released, that can also indicate that we have a chemical change. And lastly, the release of light. Understand that there's some chemical changes that result in a chemical reaction that is going to create light. So for example, here we have a firefly, just the proteins in it being utilized in order to illuminate specifically animal specimen, okay? Now, in the in-class worksheet, I have an exercise in which we are going to indicate if any of these changes represent a physical change or a chemical change. Now, similar to what we did before, we're going to utilize P for physical change, C for chemical change, and let's do it as a group right now. So, number one, glass breaking, is that a physical change or a chemical change? Great job. That's a physical change. When you are hammering wood together, great. That's a physical change. Rusting a bicycle, chemical. Melting butter, that is a physical change. Remember, phase changes are always physical changes. Now, burning butter, that's different. When you burn it, it's a chemical change. Melting it is not a chemical change, it's just physical. When we're separating sand from gravel, great, that is a physical change. Bleaching your hair, yes, that's a chemical change. So you always have to watch out who does your hair, because that is a chemical change. That is serious if it's not done the right way. Frying an egg is in the examples given before. Excellent, that is a chemical change. Squeezing oranges for juice. Excellent, that is a physical change. And lastly, melting ice. Great, that is a physical change. Any questions? Understanding what is the difference between a physical change and a chemical change. Excellent. So now we are going to move on to section 3.3, where we are going to talk about temperature. So what is temperature? That is something that, you know, we have heard the term living our lives every day. The definition of temperature is actually a measure of how hot or cold an object is compared to one another. It actually indicates the heat flow from objects that have a higher temperature to an object that has lower temperature. So heat is always transferred from something that is hotter to something that is cooler. And the instrument that we use in order to measure temperature is called a thermometer. Now, when it comes to the units of measurements for temperature, we are going to have several ones. We can have degrees Celsius, which is utilized in all of North America except us in the US. We can have degrees Fahrenheit, which is only utilized in the US. And we can also have Kelvin units. And Kelvin, when Kelvin is measured, understand that the abbreviation for it is going to be a capital K. Now, the thermometer that I have here is going to illustrate what is the conversions between degrees Celsius and degrees Fahrenheit for specifically the temperature of the human body. So let me just write it here. We can see that the temperature of the human body is normal within a range. So it doesn't have a set temperature that we're looking at, unless we're looking at the average temperature of a human body. So you can see the normal range for the temperature in a human body goes from 96.8 up until right at 100.4. If it's higher than 100.4 degrees Fahrenheit, so I'm just referring to degrees Fahrenheit right now, all the way up to 105.8, that is called a fever. Past 105.8, then that is called hyperthermia. Okay, and as you can see, if the body temperature keeps on increasing, this may lead to death. Now, body temperature can also get cold. So if the body temperature actually is reduced below that 96.8 degrees Fahrenheit, that is called hypothermia. To be honest with you guys, I don't know the range of how low the body needs to get in order to cause death. But if the body temperature actually is reduced really, really low, it can also lead to death. It's just that it's not illustrated in this thermometer. Now, one of the things is that you can see in the column right below the degrees Fahrenheit that on the other side of it, we have degrees Celsius, okay? And that means that we can actually interconvert between the degrees Fahrenheit and the degrees Celsius. We also have equations to convert things from Fahrenheit to Celsius, Fahrenheit to Kelvin, so on and so forth. Those equations, as you can see, are given here. We have transitions from Celsius to Kelvin, from Kelvin to Celsius, from Celsius to Fahrenheit, and Fahrenheit to Celsius. When we are doing transitions between Fahrenheit and Kelvin, then understand that we need the last equation and the second equation to completely do that conversion. So one of the things that is important that you guys actually study, and The question that you have, Victoria, I actually don't know the answer. Now, when it comes to what do I need to know in terms of temperature, you guys need to know what is the definition. And because we have been studying the different mathematical operations and how to do math, you need to be able to apply these equations to do a number of calculations in order to convert from the different temperature units. So as you can see here in part C of the in-class worksheet, we have a series of conversions between the different units for temperature. I pasted onto the slide the equations that I just introduced to you guys. So at this time, I'm going to give you guys about 2 minutes to do the conversions for the following temperature conversions. In the first one, we're converting 16 degrees Celsius to Fahrenheit. In the next one, we're going to do 114 degrees Fahrenheit to Kelvin. And lastly, we are going to do the conversions between 19 Kelvin to Celsius. When it comes to these problems for the exam, understand that the final answer must have the same number of sig figs as the temperature measurement given. So that's how I do temperature conversions. So in the first one, we need 2 sig figs. In the second one, we need 3 sig figs. In the third one, we need 3 sig figs. The reason why we need to do this is because the values that we have here are for an equation. And remember that those are considered exact numbers. So the values that we see in each of the equations do not take, we are not counting them towards the significant figures for the measurement. So again, the result must have the same number of sig figs as the measurement, the temperature measurement given. So right now I'm going to give you guys 3 minutes to complete these conversions. Let's get started going over the following conversion problems. The first one, we are converting from degrees Celsius to degrees Fahrenheit. So, which equation do I need to use? A, B, C, or D? Excellent, equation C. So my temperature in degrees Fahrenheit is going to equal to 1.80 multiplied by that measurement in Celsius, which is 16. And then I'm going to add to 32. Remember that when it comes to this, the way that I grade this or the way that I generate these results is based on the equations that I teach you in class. I am not responsible for other equations that you may have been learning before. I grade you based on what I teach you. So when we enter this in our calculator, 1.80 times 16 plus 32, we are going to find that our calculator display shows us 60.8. Is that what people got? Excellent. So then when I round it to the correct number of 6 figs, understand that that 60.8 is going to round to 61 degrees Fahrenheit. Let's go over the second.
I had a question.
Yes, go ahead.
So on the quiz that we just did, when we did sig figs, it asked us to do, like, obviously we're doing the same amount of sig figs. So 16 degrees Celsius is 1 sig fig, or is that 2 sig figs? Because there's a rule that says any non-zero digit number is a sig fig, but when I put that number, like when I put my answer in, like what it was given, it was incorrect. Does that make sense? I don't know if I'm making sense.
No, I'm not.
So like in an answer, like so in an answer, this says this is 2 sig figs, right? Because the answer is in 16. Is that 1 sig fig or is that 2 sig figs? Because those are both 2 non-zero digit numbers.
So the measurement 16 degrees Celsius is 2 significant figures because both digits in your measurements are non-zero digits. So that is the first rule that we learn when it comes to sig figs. That's rule 1A.
Okay, thank you.
No problem. So number 2, we are transitioning from Fahrenheit to Kelvin. So when we are transitioning from Fahrenheit to Kelvin, we need 2 equations. What are the 2 equations that we need? Great job. First, we need letter D followed by A. Okay, so that is what we're going to do here. First, we're going to use equation D, which says that the temperature in Celsius is going to equal that 114 minus 32 divided by 1.80. So what do we get from that? That's the calculator display that I got, 45.5555555, and it has a 6 at the end, right? I'm just going to put the 3 dots, okay? So we take this value, okay? And then we are going to use it in the next one, which means that when we have Kelvin, we're going to use that 45.555. And then we are going to add it to 273. Give me a moment because my calculator just turned off. And then from there, we get 318.555, and then I'm going to do the whole bunch of dots. Okay. So from there, we need to round it to 3 sig figs. Excellent. So this is 319 Kelvin. Okay, any questions so far? Then let's do the last one, where we have 19 Kelvin. And we have to change it to Celsius. Okay, which equation do we need? Great, we're going to use letter B. So our temperature in Celsius is going to be the temperature in Kelvin, which is 19, and we're going to subtract it from 273. So this is going to give us a negative value. We get a value of 254 degrees Celsius. Now, understand that you started with 19 Kelvin. So when we round negative 254 to 2 sig figs, what is going to be our answer? Great job, you guys. Negative 250. Any questions on the different ways that we can convert the different temperature units? In chemistry, understanding temperature units, it is important because depending on the instrumentation that you use, then you are going to see any of these units being utilized. Most laboratories, whenever we are doing experiments, the units that we use are either Kelvin or Celsius. Fahrenheit, at least in my experience and my years of research, we didn't tend to use it. And also, you guys, if you need to travel somewhere in North America, if you're going to Canada or if you're going to Mexico, then you will see that the temperatures are given in degrees Celsius. So it is also important to see what is the relationship between what we have here in the United States compared to our neighbors of the north and also south. So that's another way why we need to learn temperature conversions. Excellent. Since there are no questions, let's move on to the next concept, which is section 3.4, where we are going to learn about energy. Energy is defined as the property which is manifested as the capacity to perform work. And understand that whenever we're talking about work in chemistry, it's going to be those activities that cause motion or interaction of molecules. When it comes to energy, it has units of joules, which you can see that it can be given by the capital letter J, or calories, which its abbreviation is little c-a-l. There is a relationship between the calorie unit and joules, and you can see that the conversion of it is that 1 calorie in terms of energy equals 4.184 joules, and that is an exact conversion. Understand that for the exam, this conversion, make sure that you write it in your notes for whenever you have to do those transitions between energy calories and joules. Additionally, when it comes to energy, understand that there are different types of energy. The main two families of energies that we have around are kinetic energy, which is the energy of motion, and understand that there are other energies that actually come from movement. So in terms of the energies that come from movements, they include chemical energy, which is the energy due to the motion of an object. Electrical energy, which is the energy from the flow of an electric charge. We have thermal energy, which is another word for heat, which is actually caused by the vibration or the movement of particles. We have radiant energy, which is another word for light energy. Which is given by the electromagnetic energy that makes those waves travel. And then we also have sound energy, which is the vibration that is transferred from an object in a wave to produce sound. Now, we also have energy that is stored, and the energy that is stored in an object is called potential energy. There are energies that similarly are stored and they can be used for later use. So you can see that chemical energy, which is the energy that is stored in bonds and atoms and even in molecules, is one of those energies that are stored, that is kind of like within the umbrella of potential energy. Nuclear energy, which is the one that it is stored in the atom's nuclei. We can also have gravitational energy, which is the energy stored in an object based on its height. We also have elastic energy, which is the energy that is stored in an elastic object. Now, understand that in this course, out of all of the energies, the ones that we mainly focus are going to be kinetic, potential, chemical, thermal. Those are the ones that we most commonly deal with in this course. So, since we are talking about energy, one of the things in which we extract energy from is from nutrition. So, whenever we eat food, or if you pay attention to food labels, you will see that the labels say the word calories, because remember, calories is a unit for energy. So in food and beverages, we can actually extract energy. Now, depending on your physical activity, understand that those calories can also be used. So our body functions actually utilize those energies. Physical activity utilize those energies. So to give you guys an example, as you can see here, chemical energy that comes from the carbohydrates you consume, the proteins you consume, the fats you consume, is how our body is energized. And all of that is the energy that is stored in the bonds of those three particular biomolecules. Now, if you engage yourself in physical activity, so for example, here we have an example of somebody that is swimming, understand that 1 hour of swimming actually utilize, in terms of that energy calories that I mentioned a few moments ago, about 500,000 calories of energy. Now, you may notice that when it comes to the energy that we are talking about that is highlighted in green, which is the one that is in food, we see calories with a capital C. But then when I look at the words below the swimming, the calorie is in a small letter. And that is because we're going to see in a few moments that those energy calories, the one with the letter C, that is larger, that is nutritional calories. It is still related to the calories that I introduced to you guys a few moments ago. It's just that the values are a little bit different. Now, You may be thinking, how is it that we get these values for energies whenever we see that these carbs, these proteins, these fats are going to produce this chemical energy? Well, those are going to be measured in an instrument that is called a calorimeter, okay? As you can see, a calorimeter, overall, what it does is that you have a food sample that you see it here, okay, which is going to undergo a combustion reaction. So in a combustion reaction, your food will combine with O2 gas. Okay, that's where the oxygen that you see there. Now, this is going to produce CO2 in gas form. It's going to produce water in gas form, but it's going to produce heat. That's where you see the fire specifically. So this heat that is generated, then what it does is that it's transferred into the surrounding water in the device. When that heat is released, the thermometer can be utilized to capture that difference in temperature from the starting point of the calorimeter to when the food sample has undergone combustion. Then understand that there's actual equations that can be utilized in which you can relate that temperature difference, which is from the release of that energy from the combusted food, to how does that correspond to heat overall contained in the food. So that's basically how a calorimeter actually works. Now, when it comes to energy and nutrition, as I was mentioning to you guys a few moments ago, now locally we have in many instances food labels that are going to tell us how many energy calories we can obtain for certain foods. So that's why food labels are there to guide you. Now, as I mentioned a few moments ago, understand that the energy calories are related to nutritional calories. In terms of the difference between a nutritional calorie and the unit of calorie, their relationship is that 1 nutritional calorie equals 1,000 calories. In other words, 1 nutritional calorie equals 1 kilocalorie. Remember that all we did here is that we changed the value of 1,000 by the prefix of 1,000, which is kilo. Now, one of the things is that we can actually calculate how many nutritional calories we have in a particular food, okay? So I'm going to illustrate to you guys how utilizing a nutrition facts label, we can actually see how many nutritional calories our food has. It is important to memorize, and is actually not complicated to know that whenever we are calculating the nutritional calories in a nutritional facts label, the carbohydrates contribute 4 nutritional calories, the fat contributes 9 nutritional calories, the protein contributes 4 nutritional calories. As you can see in table 3.7, we already have those outlined. So this is another table that it is important for you guys to have in exam 1. So let's look at the following food label that we have here for snack crackers, okay? As you can see, the serving here is around 14 crackers, So if you want to be a little bit more conscious of like, oh, okay, if the crackers are not in full form and they have different shapes, then you can measure in terms of their mass, how many crackers you need, okay, which is 31 grams. So approximately, that's 14 crackers. Now, we can see here that we have that those 14 crackers are going to contribute 120 nutritional calories per serving. Now, where did those 120 nutritional calories come from? By looking at specifically at 3 pieces of information in your nutrition facts label. And that is going to be the fat, the carbs or carbohydrates, and the proteins. So those 3 biomolecules are the only things that are going to contribute to that chemical energy that can be derived from food. Again, fat, carbohydrate, and protein. So if we utilize the table 3.7 and the information given, then we can see where that 120 came from. So we write down the information in the food label. We look at the fat, and in terms of the fat, we have 4 grams. In terms of carbohydrates, which I'm going to abbreviate as carbs, you can see that this is 19 grams. When it comes to the proteins, we have specifically 2 grams. As I mentioned, understand that every gram of fat is going to contribute 9 kilocalories of energy. In other words, 9 nutritional calories per gram. The carbs are going to contribute 4 kilocalories per serving per gram. And the proteins contribute 4 kilocalories per gram. So utilizing that, I'm going to do my multiplications. So 9 times 4, that's 36 kilocalories that are coming from the fat. We have 76 kilocalories coming from the carbs and 8 kilocalories coming from the protein. Now, when we add these 3 amounts, we see that this equals 120 kilocalories, which is where this number of 120 comes from. So as you can see, this is how these nutritional calories can be accounted for in a nutrition facts label. Now, I want to do some examples so we can actually notice what are nutrition facts that are out there. And these are maybe products that you may be consuming or you are familiar with, or maybe for those students that are in kinesiology and maybe, you know, thinking also to get into getting a minor in nutrition. These are things that need to be conscious, especially because all of us have to eat food in order to put nutrients in the body. But we also have to be conscious of what is out there for us and, you know, how food labels are presented nowadays. So let's do the particular example. So here we have the following product, which is Nature Valley Protein Chewy Bars, okay? So as you can see here, we have the nutrition facts label, okay? And we are going to see that this is labeled as a protein chewy bar. Now, I'm going to write down in the corner the information here because it's a little bit on the blurry side. So this specifically, in terms of fat, it has 12 grams. In terms of carbohydrates, it has 14 grams. In terms of protein, it has 10 grams, okay? So as you can see, when it comes to the serving size in grams, the label told me that the serving size is 40 grams. Put a 1 in the chat if you understand where I got those 40. So just in case, for those students that are a little bit shy, that's where I got the 40. Okay. Now, you can see that the food label is telling me already that this bar is 190 calories. Okay. Now, instead of being guided by what is in the nutrition facts label, let's do the calculation ourselves. So, from fat, if this is 9 kcal, and remember that 1 kcal is 1 nutritional calorie. The carbs are going to be 4 kilocalories. The protein is 4 kilocalories. So take a moment while I fill this in and do the calculation on your side. I know that you guys can be faster than me. Excellent. That's what I got also. So this actually has 204 nutritional calories. Okay. Now, some of you out there may be like, oh, what? My food label is not the actual calculation. This can happen, you guys. It can happen. I'm not claiming that everybody has the exact numbers. I'm just illustrating and doing an exercise. Okay. So based on that, you can see that this is actually 204 kilocalories, or in other words, 204 nutritional calories. Some people claim that these numbers need to be adjusted because of the fiber that is in it. Understand that biochemically, for chemical standards, fiber doesn't contribute any energy, because fiber is just in the body, not to be processed. It's just to push things around so they can exit the body nicely. Fiber does not contribute energy. So I really don't know from a nutritional standpoint how they got that number. Okay. When it comes to sig figs and the nutrition and these problems, I let you guys use the whole number. I don't tell you guys to round. So use the result that you get. So this is simply by looking at the food label. Total carbohydrate, it says 14. Total fat, it says 12. Protein, it says 10. That's where we got the numbers from the food label itself. Now, as you can see, when you look first at the box, it says this is a protein chewy bar. But let's look at the third question that we have here. What is the major source of calories? in this chewy bar, meaning that when I look at my contributor for calories, when I look at these numbers, what contributes the most? Nutritional calories here. Excellent. Fat. So this is to illustrate that maybe in the future, you may have clients or yourself will be undergoing certain dietary restrictions. And then whenever you are utilizing food products, be conscious of your food labels. Be conscious of what does it mean at the biochemical level, because the food label can tell you something, but then because of the biochemical needs and the goals that you may have, you have to be conscious of like, what do these numbers really mean? So let's say that you're trying to do a low fat, high protein bar, and you're trying to search out there for the best one for your goals. You may see that this bar may or may not be for what you're looking for, okay? Should we do one more practice problem? Excellent. So this is something that just came through me searching. I think if I didn't do a PhD in organic chemistry, I would have done food chemistry. When I was an undergrad at the University of Wisconsin-Madison, food chemistry was not one of the majors, but now as an adult, I think that would have been one of the things that I would have been very interested in. I think I can still go back to school and pursue a degree on this. So when it comes to looking at food labels and all this kind of stuff, it is very popular nowadays to put protein in everything. And the other day, while doing searches, preparing the lecture for this topic, I came across protein popcorn. Put a 1 in the chat if you have heard of protein popcorn. There you go. Some people have heard about it. I was very surprised. This is the first time I've ever seen this. I didn't know that there was such a thing as, oh, there you go. Some people have tried it. I didn't know that this product actually existed, okay? So similarly to what we did before, let's actually write down what is the serving size, what's going to be the calories, and what is the major source of those nutritional calories in this food item. So I'm going to give you guys about 2 minutes to answer those 3 questions. Excellent. I see that people are already putting the answers in the chat, and we can see that here our serving size is about 60 grams. And I don't know if it happens to you guys, but especially things like this in a bag, like sometimes I have to remove it from the bag because if I sit with the bag, I don't know, I will overeat. I don't know. Put a 1 in the chat if you may be knowing somebody that is like that. I am Dr. Luz Carrillo, and I overeat if I sit with the bag in front of me. So things like this, I'm like, okay, I need to have just a little bit. Let me put it in the plate. If I have seconds, okay, but I cannot sit with the bag in front of me. Excellent. When it comes to the calories in the serving, again, from fat, we're going to multiply it times 8 grams. So that is 72. Carbohydrates, we're going to multiply it times 40. Protein, we are going to multiply it times 10 grams. This is 160. When we add these, this is 272 nutritional calories. Let me change the units here. Oh no, those are good. And lastly, just like you guys illustrated, carbs are the main food source here. Okay. Oh, barbecue, yes. Oh, and by the way, again, I'm a snacker. I'm going to accept it. I found the other day this tortilla chips that have, you know, street elote flavor, AKA they have cheese in it. They have, you know, tajin in it. Oh my God, I live for those. Oh, those are so good. It's from the brand Late July. Is it Late July? It's late July. Oh, so good. Those chips have my heart. Ooh. Ooh, the sabritones, yes. And then you put some Valentina in it and some, you know, lemon in it, you know, lime. Oh, so good. Yeah, we can talk about snacks and all this. But again, I hope that this illustrates to you guys how, you know, food labels sometimes, just like in this example, the information given in the nutritional calories is exact, and then other times it may be a little bit different. I really don't have an answer in terms of why is it that there are deviations in the calculations. I just know that they do exist. But I just want to illustrate, see, now you guys in the chat are making me hungry. And it's snack time for me. Like I've been talking for an hour and a half, now I need a snack. I think I'm just gonna have, I'm not trying to make anybody hungry. I'm gonna have some pineapple and tajin because I have pineapple at home. Oh, there's nothing like fruit, watermelon, pineapple, cucumbers. Whew. So good. And I don't know if tajin is good for you, but it's tasty. Oh, with mango. Yes, Jessica, mango and tajin. That's my other favorite. Okay, well, this is where we're going to stop before we are all hungry and about to pass out. So right now, are there any questions in terms of energy in food? If we are giving a food label, how we actually calculate the energy that is contributed by the fat, the carbohydrate, or the protein? Excellent. Since there are no questions at this time, we are going to go on break. Right now is 10:36. We are going to go on break until 10:45.